Discipline. So many things seem to change in our industry and with our roles as software engineers. I changed many of my opinions and also started adapting to new realities. But one thing that did not change since I started my profession in 2016 is what differentiates a good and healthy project from a failing one. Discipline. It has never been easier to be lazy. Whenever something does not work properly, just ask the robot once more to fix the issue. Wait, ask again, pay for tokens, and repeat. And you can get away with almost 0% brain usage while eventually fixing the problem. And whenever convenience is cheap, finding motivation doing hard things becomes difficult. Even worse, I started noticing additional anxiety when spending significant amounts of brain power in what I call project investments. Why burning 4 hours of my time when AI maybe can solve any issue in 20 minutes, maybe in 30 minutes, maybe in 2 hours? It has never been harder using discipline, and yet I stand by the statement that discipline is the #1 most important part of any good software project. Keep a suitable architecture, build good test fixtures and tests, and invest in a good developer experience. Today's topic is for all technical leads working on JVM-based projects, sharing my absolute favorite trick, improving developer experience massively. I call it deep debugging, and I also wrote a blog post about it quite some time ago. It might be a little bit surprising, but almost all projects I have worked with in the recent years as a system were not just a single JVM process, but multiple. Some of them being classic server-client architecture, but others being worker processes, or some interplay between logic and build time with code running at run or test time. And while IntelliJ makes debugging easy, just pressing the debug button usually debugs only known processes such as tests, application runs, or build scripts. Today I will show a not really documented trick, providing a beautiful developer experience allowing to debug all parts of such systems by just pressing debug in IntelliJ. We start by looking at a very simple JVM project that just prints hello world. And we will create a dedicated worker process from our main process. To define the worker, we just call into any heavy calculation and then print the result to the system out. To launch our worker from our main process, we can use Java's process builder APIs. We have to provide any executable file. We can use the process handle.current to get the current Java executable executing the main process already. We have to provide a class path for every Java application, and we can use the system property java.class.path to provide the same class path as the main process. Last, we provide the worker KT main class and start the work process. Last thing we have to do is read the input stream to provide or to parse the result of our calculation. Once this result is returned, we can just print it in our main process. Now, when we execute this, we see that I did a small mistake. We have to use a .trim to pass the number correctly, but now we can see the value 42 being returned correctly from our worker process. Now let's add some breakpoints in the main, but also in the worker process, and then start debugging. As you can see, the breakpoint in main will hit, so does the launch worker function, but the breakpoint within the worker was not breaking at all. In order to create a good developer experience, we first need to understand how debugging on the JVM works. We have to provide the JWP agent library, configure it to use sockets as a transport. We can optionally tell it to run in server mode, wait until the debugger is attached, and then select a binding port. Now, once we start debugging this application, we can see the first breakpoint hitting as usual. But resuming the application will now wait for the worker process, which also waits for us to attach a debugger. Using the attach to process tool from IntelliJ and connecting to this process will finally kick it off, and we can see the worker breakpoint also hitting and the result of the calculation again showing 42. However, this setup requires manually attaching the debugger, which is certainly not the best developer experience. Debugging our main part also does not require manually attaching a debugger. If we try to understand how IntelliJ works under the hood, we can maybe leverage this to make the debug button work for all subprocesses as well. We see that setting up a debugging session requires one server and one client which connect through a single port. When multiple processes are involved, we need something that manages open ports. Luckily, IntelliJ has a very simple internal component called the Debugger Dispatcher Server, which we can communicate with, opening new debug servers on the fly. When pressing debug, the debug dispatch port is provided to our build tool as a system property, idea.debugger.dispatch.port. When available, we can wire this property into our main application, letting it dispatch new debug sessions on the fly. We can do this in our sample project, which is using Gradle, by configuring the run task of our application. Within this configuration block, we will request the idea.debugger.dispatch.port system property from Gradle, and if present, we can just provide the same system property using the same key for our application run. Inside the main part of our application, we can now request this property using system.get property. And if we print the port that is available in system.out, we can check if there's a difference between running in debug versus regular mode. Now let's launch it in normal mode without a debugger. And we can clearly see that there's no debugger dispatch port provided. Not so surprising. Now it gets interesting once we launch this application with a debugger. We can now see that indeed at runtime there is a debugger dispatch port available to us. Now let's try to use this debugger dispatch to create a new debug session dynamically and provide the corresponding debugger arguments. The first thing after getting the debugger dispatch port is to find a new free port for us. Once we have a new debug port assigned, we can connect to the dispatch port and use a simple data output stream to start issuing a new debug session. We have to send 3 strings to IntelliJ to start a new session. The first one being the ID of the debugger entity we want to use, in our case Gradle JVM. The second one being the name of the session. And the third one providing the arguments for the corresponding debugger. In our case, we will provide the debug server port we just found to be free. By the way, as far as I can tell, this protocol is not documented somewhere, so if you like having such insights, maybe consider subscribing to this channel. While I do not post that regularly, I might share more such interesting tricks in the future. Once IntelliJ has finished setting up the debug server, it will send 1 byte in return, so we can wait for this byte and then finally return the debug arguments necessary. We only have to replace the port with a dynamically chosen one. Finally, we have to switch from server mode to client mode, since IntelliJ will host the debug server for us. And now let's replace the hard-coded debug arguments with the dynamically created create debug arguments. Now, finally, once we press debug in IntelliJ, we can see that it breaks in the main process, but automatically also in the worker process. And we can see even the tab being called worker process. So we finally got the UX that we wanted. We can maybe now even extend it by trying to give this worker process a dedicated name. We therefore just pipe this name into the arguments we sent to IntelliJ. And then we can create maybe a foo and the bar worker process. Once we launch this in debug mode, we should see that there is a worker process tab that is called foo, and later on a worker process tab that is called bar, which automatically breaks. We can go even one step further, launching those processes in parallel, just launching them within a thread. And now we should be able to switch between a worker process bar and the worker process foo automatically within IntelliJ. And as you can see, both are breaking, and we in both cases can debug the application. In order to use this tabbed debugger, make sure that the run configuration has the debug forked Gradle task and separate debug tabs selected, and consider storing this run configuration as a project file and commit it to Git.